No, I mean, sorry, not get nowhere. It's more that I cannot solve.
Alright. Alright, welcome back to day 20 of LeetCode grind. Solve or go home. 30 minutes solve or go home. Okay. Let's see. Brick wall. Okay. There's a brick wall in front of you. The wall is rectangular and has several rows of bricks. Bricks have the same height but different widths. You want to draw a vertical line from top to the bottom and cross the least bricks. Brick wall is represented by a list of rows. Each row is a list of integers representing the width of each brick in this row from left to right. If your line goes through the edge of a brick, then the brick is not considered cross. You need to find out how to draw the line to cross the least bricks and return the number of cross bricks. You cannot just draw a line along just two of the vertical edges on the wall, in which case the line will obviously cross no bricks. Okay. So
Yeah, so let's analyze what you should do.
So based on the explanation, it looks like you want to find the edges as much as possible. Because it's
Okay, what do you mean by edges?
like if you look at the example where it just goes straight from 2, it only hits 2 and 4 because it goes through a 1 whole path and then a 3, like that. Whatever, I don't know what that crevice is called. It's like whatever's not taken up. Like I guess each brick has like a small space in between another brick. So then, if you're going downward, you can technically just go through an open path if it exists.
Okay. Yeah, I mean that's a good start. So, are you claiming that the best path will be
The one with the most
in between stuff?
Yeah, the one with the most in betweens, because that means you're hitting the least bricks, right? Actually, these lines,
yeah, sure.
lines. Wait, it says you cannot draw a line. Okay, that's something else. But what does it say? The lines. Oh, it has to be a vertical line. Okay, that's okay. You can't do diagonal. Sorry.
Right? And it cannot be at the start or the end.
What do you mean by start it? Oh, you cannot use the first brick and
Because then it will go to 0. Like it's trivially solved.
Yeah. Oh, that's, you mean like the out of bounds base. You can't use out of bounds.
If you're all the way at the left, then it goes through nothing.
And all the right also goes through nothing. Yeah. Okay.
Right. So okay. I guess what happens if let's say every single input was identical.
Sure.
And like let's say it was all like bricks of size 2.
Mm-hmm. Then you have to hit every brick. There's no other way around it.
Exactly. So
so you want to look for differing lengths, basically. That's the sweet spot.
I mean, no, well, that's a case where hang on one sec.
All right. Wait a minute. Can you do this?
Okay, sorry, I'm back.
No probs.
All right. So, all right. Did you think about it?
I was thinking maybe trying to line up the arrays.
Shut up,
Is there
Siri.
something else I can help?
Absolutely. Okay.
I was thinking of trying to
Okay.
build.
Let me know if there's anything else.
Yeah, I was thinking of
Alright.
trying to line up the arrays so that they're all the same length, and then I put in zeros in spaces where there's that gap, and I can just just go through the arrays straight down and see which one is the least path.
Okay, so as you mentioned, the maximum that you can return is all of it, right? One per row.
Yeah.
And you're saying that in the gaps, you basically have the minimum. So basically, one of these gap locations is going to be where you have the most that either start or end there,
Mm-hmm.
and because they start or end there, you skip it.
Yeah.
Okay, so why don't we somehow just keep track of every position that can be a gap?
Okay. So basically, after every brick length, there's always a gap.
Mhm.
Yeah. So if you're
Right.
if
So
you're
you got
saying,
a 0, but you don't care about 0.
yeah, we don't
So
care about
you're
it.
like,
We can't
okay,
use it. So yeah.
in the 1, 2, 2, 1, then there's a gap at position 1, a
Yeah.
gap at position 3, 5, and 6, right?
Yeah.
And technically, we don't have to worry about 6. So it's just 1, 3, and 5
Mm-hmm.
in that case.
Yeah.
Right.
So I see. So basically, the array has the brick length. So basically,
Mhm.
after 1 there's a gap. So that means after position 0 there's a gap.
Mhm.
And then after position 2 spans 2 indexes. So after position, what is it? 0, 1. After position 2 there's another gap. And after position 4 there's another gap.
Wait. Why 2?
Index 2 is actually position 3 if you think about it another way. So what I'm saying is, so your array is 1, 2, 2, 1, right? So 1 is position 0, right? So after
Yep.
position 0 there's a gap. So position.
No, but we don't care about 0. Well, I guess you could if you
No, I'm
like,
saying after position 0, not before position 0. Because index arrays start at position 0, right? So this is the 0th index. After the 0th index, there's a gap. That's what I mean to say.
right, there's a gap after position.
After
Okay, sure.
after index 0, there is a gap. After index 2, there's another gap. And then after index 4, there is another gap. And then after index 5, there's one, but we don't care about it.
What? Oh. And no, that's not right. It's if you're doing 0 indexed, it's gonna be 1, 3, 5.
No, you're
0,
1,
1, 3, 5.
1, 3, 5 is the position of the gap. I'm saying after index 0 there's a gap. So what you're saying is at index 0 there is a gap. It's the same statement.
Okay, if it's after index 0.
After index 0 is
after
index 1, yeah. That's what I mean. So this is at index 3 there's a gap.
Also at index 2.
And then at index 5 there's a gap.
What is an index?
I'm speaking of indexes as like an array. So imagine visualizing this as an array where it's index.
You're building the whole array.
I'm not building. I'm just like imagining it as an array, because then some bricks take more length, some bricks take less length. So then I'm saying if this array was built out, it would be like 1, 1, 1, 1, 1, 1. Like whatever. There's 4, 6. Yeah, 6 of these. 1, 2, 3, 4, 5, 6. So this would be what the array looks like. So that means there's a gap here. There's a gap here. There's a gap here. And then there's a gap at the end. That's what I'm talking. If you were to expand the bricks out to 1, 1, 1, 1s.
Alright, so this is a fine approach. However, if you look at the note, What's the first line of the note?
The width sum of the bricks in different rows are the same and won't exceed index. Yeah, what's wrong with that?
Right. So you're gonna initialize a row of index. Oh man.
No, I'm not actually building the array. I'm visualizing as an array.
Okay, sure.
Yeah, no, I'm just speaking right now. I'm not coding it like this.
Okay.
Yeah, so I'm thinking like you want like a kind of like an array, kind of maybe an array, but where you have the index that you have the gap at. So I'm just storing the indexes that you have gaps. So at index 1 there's one gap. At index 3 there's a gap. At index 5 there's a gap. So
that's right.
Yeah, so it would kind of be like 0 or maybe a dictionary. Maybe like 0. Actually, no, it's a set. It's a set. We just need a set. Set of 0, 3, and 5 for the first row, and then the next row is.
You mean 1, 3, and 5?
Yeah, my bad. Okay, and then the next one is index 3. That's 3. No, index. Wait, is that index? That's 4.
3 and 4.
4 and
3.
Is it 3? Whoa, wait. Am I confusing myself? Okay, wait, 1. Yeah,
3 and 4.
Yeah, it's 3 and 4. Yeah. Okay, yeah. So basically, you loop through the bricks, and then you just build the sets based on like the length of the bricks.
Okay. Why do we want sets? Because it looks like 3 shows up twice now. So
no. It's a set per, right? Set per row, unless you want one overarching one. Or maybe it's a dictionary, of each array, and then each array has a set.
Well, I don't think we need to do that. If the brick wall was size 2, 2 rows tall, then your best gap is the one where you go 3 and 3, right? It cuts through everything, and then
yeah, because you get 0 at that point. Yeah.
Right, and the reason that is because the count of things at 3 is greater than everything else.
Oh, so what you're saying is instead of doing set, do a dictionary and just count the number of gaps and then just return the highest.
Exactly. So you're doing the same thing, but now you're keeping track of.
Yeah. I see. Okay, yeah, that's simple then. Okay, so we want a dictionary, and then we want to loop through all of these arrays, and then just build a count of each gap into it and just return the largest gap.
Okay, and then you have to somehow handle the last case and the first case and the case where there are no
gaps
elements.
Wait, right. What is last case and first case?
In the example given, the first case is 0, the last case is 6.
What?
Position 0 and position 6 will always be 0. Or sorry, it will always have a count of length.
No. Wait, what are you talking about? Position 0. You're talking about the out of bounds stuff?
Yeah.
That won't. You can't put that into it because then we don't loop. We don't handle that.
Okay. Then just making sure you're aware of that case.
Yeah. Those can't happen. I don't think. Pretty sure it can't happen.
Okay. Yeah. I mean, you will have to code with that in mind.
Yeah. So I think it's possible for the last one to happen if you don't account for it, but the first one definitely can't happen because no one is tracking that. We're starting from index 0, so it's gonna start from here. You can't have the 0th index as a gap. It's possible to have the last index as a gap if you don't handle that, but yeah.
Then let's code it.
Okay, so for I in wall Maria. Oh no. For Titan in wall. Okay, so we got so each thing is an array. Okay, so for okay, so I have all of these. Okay, so it should be dict if I not in dict dict I plus, oh, it's I plus 1. No, I is, yeah, I is the index, yeah, so it's I plus 1. Should be correct.
No, I is not the index.
No, I is the length of the brick, which I consider to be the index. If I'm thinking of it as an array, if you understand what I'm saying.
Sure.
Yeah, it's fine. I plus 1 man dict I plus 1 equals 1, else dict I plus 1.
What is this I plus 1 stuff?
I plus 1 is because you're doing the index after it is a gap. So if you look at 1, wait, no, the length of 1.
So the gaps don't take up any space.
Yeah, I know. Wait. Okay, yeah. You don't need a plus 1. It's just I.
Well, not quite. You need to know where you are. So if you're the first element, then you're at 1. If the second element, you're at 1 plus 2 is 3, and then the third element, you're at 1 plus 2 is 5.
Oh right, you can't just use I.
That's what I'm saying. It's like I don't know where this plus 1 stuff's coming from.
Okay, then I'm just gonna have a prev count and just have a running total. Wait, can you add plus equals 1 here, or is that immutable?
Plus equals 1 is fine.
Okay. Right, and then, yeah. And then prev index.
Okay, there's a slight issue here, which is the last guy is also counted.
Yeah, I need to account.
Which you can delete later, or you can handle it now.
Yeah, I'm gonna handle it now. For I, okay, yeah. So, index else, just else, and then if wait. I can just do only loop through till the second to last index.
Okay.
I think the syntax is 1 to -1 and to -2. Or is it just that?
It's colon minus 1.
Colon minus 1 gets me all the way to the last index?
Everything except the last one.
Everything except for the last one?
Mm-hmm.
Okay. Yep. Okay. And then I will have a dictionary built with everything. Yes. Alright, let me print the dictionary. So it's saying use index 3 basically, because that's the largest one. But then that doesn't.
Why is index 3 the largest one?
Oh, it's the largest count. Actually, no, index 1 also.
No, it's not.
It says right here.
Index 3 is only 3, right?
Yeah. Oh, there's some 4s here. Never mind. Index 2 is 4. Is that even correct?
Index 4 is 2. Not index 2 is 4.
Wait. No, index 4 is 4.
That's right.
1.
And that's the right answer because
Yeah. Oh, there's 6 of these. That's why. Okay. So you have to return the maximum, but also you have to return the length of the bricks minus that.
right.
Wait. You could just call max on dict, right? Wait, no. No, that would just give me the key max, right? That doesn't give me the value max.
You can do dot values.
What is it? Dict dot values like that.
Mm-hmm.
So return max, and then when bricks minus that. But I still need to account for the case where there's nothing in the dictionary, right? So there's nothing in there. What case is there nothing? Oh, that means just the whole thing is filled up. That's the only scenario where there's nothing in the dictionary. In that case,
Wait, you have input is like, row 1 is the two bricks, and then row 2 is 2 bricks.
no, then there's a gap. If it's if there's 2 bricks.
Sorry, it's a brick, 1 brick of size 2.
Yeah, that's what I'm saying. So you're saying that means every row has the same number of bricks, basically.
And the same brick.
Yeah,
it's
the same size brick.
brick.
Same size brick. Yeah. So in that case, it won't. This dictionary will have nothing. Yes. And then if that case happens, that means we just return length of bricks. So I think yeah. So return. So if dict, is there like is empty or no? Or is it just if dict?
Well, if dict will mean that it's not empty.
Okay, so if not dict, wait, no, that means empty. So if dict, oh no, if dict means it's not empty. So we want it is empty, then return len bricks, and then else we return this.
Okay.
I think that's fine. Well, apparently you have to do not here. Does the not only work with equal sign? Oh, how come bricks is? Oh, it's wall. It's not bricks. Oops. Okay, that one works. Oh, I didn't give any other test cases. I guess we just build a random one. Let's give another roll. 1, 2, 1, 3. Well, what's this? It's supposed to be 6. Okay, 1, 2, 3 should add up to 6. Let's see that one. Okay, that looks good. Nice. Alright, I'm not going home. You have anything to say?
It's good. I think again you're kind of fumbling over the logic a little bit, or not quite the logic. It's the implementation. You're doing stuff like +1, and I'm like, where's this?
Oh yeah, because I was
what you're saying and what you're writing do not.
No, I was thinking in the terms of my indexing, and then I realized I was wrong, and then also realized I didn't track the index properly to get to that point, because then if I'm just pulling the brick lamps, then that doesn't get me the proper indexing. But yeah.
Good.
Do another, or you're out of time?
You can do another one.
Alright. What do I want to do today? Let's do something not too hard. Maybe a design question? There's only 2 design questions. Maybe this one?
Me too.
I don't think I did any of these, so whatever. Longest palindromic substring, longest substring without repair. Let's try this one. Okay, given a string S, find the length of the longest substring without repeating characters. Okay, I see. Okay, so given this string, I want the longest substring without. When they say substring, it has to be consecutive, right? Is that what it means?
Right.
Okay. So okay.
Yeah, subsequent and substring are different. So substring has to be consecutive. That's right.
Okay. So initial dots, just brute forcing. Don't you just loop through and then keep checking? As long as it's unique, you increase your count, and then at the end of the string, whatever your max count is, just return that.
Okay.
Is that good enough, or is there like a better way to do it?
I think there's a more efficient method.
Okay. Should we discuss
So,
that?
so let's look at the first example, right?
Mm-hmm.
So you're like, okay, I'm processing A.
Yeah.
Is this the longest I've seen?
Yes.
And it's like, yeah,
Mm-hmm.
it's 1, right? And then you go AB. Is this the longest I've seen? Like, yeah. Okay, so 2 is bigger than 1, right?
Mm-hmm.
And ABC. Is this the longest I've seen? Like, yeah. All right. So then 3 is bigger than 2, right?
Yeah.
And now you have ABC and A, right? How do you resolve that?
What do you mean by how do you resolve that?
Because now there's a repeating character.
Yeah, so that means you have to start off at A now, because ABC and A don't match, so you can't you discard the first A and you slot in the new A.
Mm-hmm.
Yeah. So now you're starting from B instead, and you're still
Right.
left 3.
Okay.
And then you go check.
So
Yeah.
right. So then, what does this remind you of? I guess like what kind of structure should you use to keep track of where you are
Keep track of where you are.
and what you've seen so far, and allows you to get rid of the stuff from the left side.
Stack, or left side, probably Q.
Right. So it's gonna be a DQ, but it's gonna be like a sliding window, right?
Yeah, sliding window Q. Okay.
So, well, that's part of it. There's the window that you have to keep track of,
Mm-hmm.
and then how do you know that when you hit A again, that you have to get rid of the other one?
Well, I think it's just like I guess it's greedy or something. Like, you just know that if you discard this A, the previous A, and you keep the current A, it's still the same length, so you might be able to keep going. So it might be worth it.
Right. How do you know that A has been seen before?
Oh, I see what you mean. I guess you can have a set.
Okay, good. That's a good idea. So you'll have a set that
Stores
where you keep track
of your current
everything
string.
inside your window,
Mm-hmm.
right?
So if it's not inside it, keep adding to your max. If it's inside it, then we pop left, and then we append the new one.
Well, you pop until you found where it is, right? 'Cause it could
Oh,
be
right. Oh, yeah. It doesn't have to be necessarily. It doesn't have to be the first one. Yeah, you're right. Okay.
Exactly. It could be, what if it was ABCC, right?
Yeah.
Then you have to pop everything pretty much, and then
A B
start
C
over
C
with.
C. Yeah. Okay. Yeah, I think I got the algo. So basically, we want to keep storing into it, and we have a max count that is our return value, and then
Okay.
as long as we can add to the set, we keep increasing it, and we keep appending it to the queue. And the second we find a duplicate, we pop until we find a duplicate, and then we
Right.
append a new one, and then we keep going until the
Right.
end of
And
the
then
string.
when do you check longest? When do you check if it should match the longest?
What do you mean? Oh, when do I check if the length is equal to the max return value?
Yeah.
I mean, you can do it at every append, I guess.
Do you need to?
Technically, wait. I think you. No. Oh wait. I mean, you don't, but then you do need to check it. I think okay, maybe every time. No, every time you append, you kind of want to check it. Yeah, I think so.
Well, okay. Let's say we just check at the very end. Let's say you keep appending and you never have a problem, right?
Mm. Oh, I see what you mean. And then, you just return the length of the DQ instead.
Right. But when you do have a problem, then what happens?
When you do have a problem, you're popping.
Right, and then before you pop, you know that.
Oh, I see. Right before you pop, you store the length.
Right, because you know that.
That was the maximum you currently have.
The second copy of this letter, you know that was the longest one where the previous condition was set. Was held.
That makes sense.
So you only really need to check when you pop and at the very end.
Okay, cool. Okay, I got it. Yeah. Okay. Sure. Okay. So we want a set and a DQ.
Okay.
So current string equals set. DQ is just call it a Q. DQ the first. I don't know. We just do it. Okay. So yeah. Okay. So for looping due to string, we want to, as long as we can append, we put it. Okay, so we want like a while thing, a while loop probably. Okay, while. Index equals 0. Index less than len s. If s in current string if it's in the current string, then we pop until we find it. So okay, so it will be q pop left. I guess I can, instead of popping, I can peek and then only pop if I need to pop it. So I'm like if. Wait, is that true? If I pop it, if I peek and then pop, then if I pop. Okay, yeah. So if I check if it's A, and it is A, then I pop it. If it's not A, I have to pop it anyway. So I'm gonna have to pop it anyway, whatever. Okay. If letter equals S. Wait, actually no. Let me just do a while letter not equal to 0. Okay, we need a ret. So ret equals 0, and then before we pop. So if it's in the current string, that means we're doing a pop operation. So we need ret equals max ret and q len. Okay, and then while letter is not equal, we pop it, and then after we're done popping, we append q dot append s index. Okay, and then so this handles all of that. What am I missing here? I don't current string. That's fine. Oh, I need to append to the current string. So yeah, so when I append to the queue, I also need to put it back into the set.
Yeah, where's your scene plot?
What do you mean my scene plot?
Oh, it's curse string.
Yeah, curse string is my scene plot. Yeah. Okay. Yes.
I feel like it's the wrong naming convention. The curse string should be your queue, and the scene plot should be your set. But whatever. If this is not confusing to you, then that's fine.
Yeah, I mean, the naming of curse string is just weird. I could just name it something better. But yeah, it was just the queue is the
No, I mean the curse string is definitely your DQ, right? It's like
okay,
you're at
fine.
ABC and then
Yeah, but then
BCD.
your set is like okay, your scene plot, right? Yeah, okay, fine. Scene
Yeah,
plot. Scene plot. And then we'll just change the queues. This one's scene plot. Okay, so and then there's the else case. You just add it to the scene plot, and you add it to the curse string. And then you increment index.
Oh, wait, okay. What's curse string of 0?
Curse string.
And what's letter also?
Oh wait, I didn't even define letter. It's wait, while.
Well, first it's S, right?
Mm-hmm.
Wait. Hey, what is this?
What's wrong with this? This is fine.
So there's length of S, which is the input string, and then if S in scene plot, first of all, the whole string is not gonna be in scene plot.
Yeah, okay, this is index. This is index. Yeah, okay. While S is not equal to curse string 0, yeah, you're peeking at it.
You mean S of index?
Yes, you're right. You pop left, okay. And then you append it back, you add it to the set. Else, you append and you add to the set. And then you increment index. Yes. Okay.
Well, also, what happens if S is equal to curse string of 0?
Then you don't pops.
No,
Oh, when S. Wait. What was the question again?
So your while loop in 13 and 14, it stops when you find that they're the same.
Yeah.
But that's not enough, right?
Oh, you still have to pop it too.
Correct.
So you gotta call it pop again, pop a Smurf again.
And also, when you're popping these things, how come scene plot's not being updated?
I updated it right here. Wait, what do you mean scene plot? Scene plot's updated right here.
No.
Oh, you mean I'm popping from the current ship, but I'm not popping it from the set.
Exactly.
Yeah, okay, my bad, yeah. So I gotta remove it too. So it's scene plots dot remove, I think.
Yeah, remove is fine.
And I also have to remove it from here also. So I'm doing doubles. So instead of doing this, I'm gonna use a helper function that does it.
What? Why are you doing S of IDX?
Why not? That's the letter.
But that letter never changes, dude.
Hey? What are you talking about?
So inside this while loop, you're always at the same index.
No, I increment by 1.
That's afterwards. But within the while loop, in lines 14 through 23, S of IDX is always the same.
Oh yeah, you're right.
I have very hard time following your logic. So what you should do is have line 17 is stored as an element somewhere, and then remove that element, right?
Yeah, no, that's fine. That's fine.
I'm confused, dude.
S of index is not equal to current string 0. Yeah, that's wait, no, S of index is the same letter. So
that's right.
That's fine. That's fine. So that's fine. I just need to store this as the stuff I'm popping out from the set.
That's fine.
Okay, and then I store it again here, and then just pop it again here. Yeah. And then the rest should be S of index.
Okay, that looks better.
Okay, then I'll need this.
I mean, technically, line 21 and 24 cancel each other out, so you don't actually need that part.
What are you talking about? 24 only triggers if it's not in scene plat.
Oh, sorry, you changed it. 18 and 21 they cancel each other.
18 and 21. Are you saying instead of removing and adding, just don't do it?
Technically, it's fine not.
Yeah, that makes sense. Okay, sure. So yeah, so we don't remove it from the set because you're gonna add it back to the set anyway. Okay, that's fine.
Exactly.
All right. So yeah, remove from the set and pop it, and then pop the last one after you've done looping, and just append the string back to the index. Yeah, so you pop it from the left and you append it to the end. Okay, that's fine.
Okay. Then what happens when you're done with all this?
When you're done with all of this, then you do one last check. You just do max of ret and len Christian. Yeah, that should be good.
Okay.
Try the empty one. Okay, cool. Alright.
Alright, nice. Good job. Again, just be very careful with your organization. I think that's by far the weakest part. Like, logic is fine and everything. Translating into code, somehow stuff gets dropped here and there.
Yeah, I think
really
that happens. That happens all the time for me though, so it's hard to fix.
Like, I think maybe when you're doing this, you should write like pseudocode and say like, oh, pop this guy, change that guy, and then fill these in with variables as you go. Because then you realize that S is not actually S of index, and that you're not actually updating the set or whatever it is, right?
Yeah.
So if you have a detailed pseudocode on what you're doing, then it's a lot easier to fill out the logic.
The thing is, this is literally pseudocode.
Right, but even so, like, you were missing steps everywhere.
Yeah,
right?
Yeah, for sure.
And like, you can kind of iterate and find it, but it's a lot cleaner to be able to write it from the ground up.
Mm-hmm.
Okay, nice.
All right, thanks.
Yeah.